Okay, so here we go with the second half of your notes for 1.3. Now, these equations are a little bit more complex. The main difference is that in these equations that I'm going to go over, the variable is on either side of each equation. So there's an x on the left-hand side, there's an x on the right-hand side. So the main thing when you see an equation that's kind of complicated like this, first thing you're going to think about doing is simplifying both sides. And that connects to our combining of like terms. So what I'm going to do first is I'm going to simplify both sides of this equation in example 2. Okay? I'm going to partly use the distributive property for that. So on the left-hand side, I am going to distribute 3 through that side. So that becomes 9x minus 6 equals, and then I distribute on the right-hand side. 7 gets distributed just through that parentheses, so that becomes 28x plus 21, and then we can't forget about that negative 31x on the end. 31x, not 3x, 31x. So when I look at this, I look at, can I simplify the left-hand side by combining like terms? Doesn't look like I can. 9x and negative 6 are not like terms. However, on the right-hand side, I can combine some like terms. 28x, negative 31x. Those combine to be negative 3x plus 21. Now I've got both sides simplified. From then on, I want to get my variables to be on the same side of the equation. So I would either move 9x to the right-hand side or move negative 3x to the left-hand side. Instinctually, I'd think of moving negative 3x to the other side by adding it. So negative 3x plus 3x is 0, and then I can combine 9x and 3x to become 12x. I'm going to write it on this right-hand side so that we have enough room. So 12x minus 6 equals 21. From there, I'm going to add 6 to both sides. 12x equals 27. Still going to run out of room, but I divide both sides by 12. Now here's a case where 27 divided by 12 is not what we'd call a nice number. So there's a couple different things you could do here. You could get a decimal. If you did 27 divided by 12, you'd see it's 2.25. I'd accept 2.25. That's fine. Or if you were to simplify this as a fraction, that fraction you think about, what could you divide 27 and 12 both by? Well, I'm thinking you could divide both of those by 3. 27 divided by 3 is 9. 12 divided by 3 is 4. So if you said 9/4, that'd be the same thing, all right? Usually I'll be clear on what I expect, fraction or decimal. Certain cases, a fraction is more useful than a decimal, and then the other way around also. So just be aware that in these types of problems specifically, I'd accept either a fraction or a decimal. Doesn't really matter to me. So right here, a couple of guided practice problems. Pause the video, work through those on your own, and then kind of pay attention to what I'm doing in the solutions. But these are, again, great times for you to stop, kind of assess where you're at, check your work, all right? So, in number 3 for this guided practice, simplifying both sides. That's going to take distribution, okay? Distribute 4 on the left-hand side, 4x minus 24. Distribute 3 on the right-hand side, 3x plus 6, okay? And then it's a matter of moving the variables to be on the same side, combining those like terms. So my thought is to subtract 3x from both sides. That's not changing the truthfulness of our equation. So the left-hand side becomes x minus 24 equals 6. Then it's just a one-step equation from there. Our work becomes much simpler the further we go. Add 24 to both sides. X is 30. And that equation is solved completely. So make sure you're paying attention to simplifying and then getting those variables to be on the same side. That allows us, that combining of like terms allows us to have the variables just on one side, which is much easier to solve in my opinion, right? So guided practice number 4, looking at this one. A lot of simplifying going on, but we just got to be careful of some of the signs here and make sure that we're not skipping anything. So on the left-hand side, distribute 3x through. That becomes 3x plus 12. Right-hand side, it's kind of weird to see, but it is a negative 2 there. So I distribute negative 2 just through that parentheses. That becomes negative 2x plus 14. And then on the end, that negative 15x is still there. We're making sure we're not forgetting that, because that's a common thing. People do that work of distributing, but then they don't, they forget about that term on the end. So just make sure we're paying attention to that. So from there, I instinctively know that on the right-hand side, I've got like terms I need to simplify. So I'm going to write out each step to make sure that I'm not missing anything in my work, okay? So on the right-hand side, my like terms, negative 2x, negative 15x, those combine to be negative 17x plus 14. And then again, it's a lot like our last example where we're going to add or subtract something from both sides. In this case, I think the most logical thing would be to add 17x to both sides. So that becomes, I'll write that a little bit better, 20x plus 12 equals 14, right? And then from there, I'm just going to kind of spill out of the box here, but subtract 12. This becomes 20x equals 2. And then divide both sides by 20. And again, you can get a fraction of 1 over 10, 1/10. Or if you just want to punch in 2 divided by 20 in your calculator, you're going to see that's 0.1. Again, either one of these answers is acceptable. They're the same number, right? Again, I will let you know when I specifically want one thing or the other. So that concludes solving these equations. Hope this was a good review. Hopefully it felt like a review. And then you're now ready to move on to the next step in the lesson. So that's probably going to be the practice. So make sure that you're, again, asking questions, working through what you need to, and just taking these steps seriously, because this progression, this is meant to be in a certain order that is going to help you kind of master these concepts and be able to do well on the checkpoints.